You are most welcome, ladies and gentlemen, to Real Impartation Moment on Tuesday Night Anatomy with Daniel Okwan. Today's section, we continue with the Skeletal System Insight. Okay, this series is going to go on until we are done with all that we need to understand regarding the skeletal system. And then we move forward to a different, system altogether, or a different section of the anatomy altogether. So my friends, if you've not watched the previous 3 videos that we've already done, my friends, you are missing a lot. Okay, they are important concepts that will make you an outstanding, anatomy student. Okay, for life. That's what I'm trying to tell you. So my friends, if you've not subscribed to this channel, kindly do so. Yes, so that anytime, new videos are uploaded only on this channel, you get the opportunity to watch it quite early than others. Okay, so that is what I want to tell you. If you've not watched the 3 videos already, please kindly get the video links and watch them, because this is going to be the part 4 of Skeletal System Insight that we've already begun. Okay, now today, last time, okay, we got to a point where we're looking at, the bone tissue. Yes. Now already I had told you that we have what you call, the skeletal tissue made up of the bone tissue, and then of course that of the cartilage. Yes. Now because we're dwelling more on the bones, we began looking at the bone tissue. And one thing that we know about the bone tissue is that we said that it's going to have cells. Now today I will spend part of my energy on the cells and also delve into the 2 kinds of bone tissue that we have. Yes, so I'll be talking about the primary bone tissue, okay, and I'll also be talking about the secondary bone tissue. I'll tell you that the primary bone tissue, where is usually the first to be laid, okay, will be called woven bone, or because the formation, okay, that kind of spicules, there's that kind of confluence of spicules giving rise to what we call trabeculae. Then we also call these kind of, spongy bone, trabecular bone. We will see that they tend to be lighter, they are lightweight, okay, and therefore you can also call them light bones, okay, or porous bones, so to speak. We will look at that. Then, we also look at the, secondary bone, which is of course the mature bone, who is going to, replace most of the time the immature bone, spongy bone that we form. Okay, we're going to look at that one. And that one, because they form that kind of layers, which you will be seeing, we call them osteons. They will have what you call Herbacean system. Because of that, we also call them, lamellar bones. Okay, that is also one useful thing that you get to know. Because that one very heavier, call it, dense bone, okay, or hard bone. Okay, that is what we are going to call these kind of bones, or may also call them, cortical bones. You are going to see them. I'll justify all these names for you. Now, but before I delve into this, the last time we got to know that if you look at the bone tissue, which is otherwise known as the osseous tissue, that's what we said, osseous tissue is going to have the cells, because connective tissue, it will as well have extracellular matrix. Okay, now we got to know that the extracellular matrix, we have what we call the inorganic component, which I told you that we should separate water, okay, from the inorganic component, because water is contributing about 25% of this, extracellular matrix of the bone. And then of course the remaining inorganic component by way of the mineral matrix, which is mainly the hydroxyapatite, the ore of the bone, the mineral of the bone that we can extract. Okay, that's what we talked about, the hydroxyapatite. We gave the formula and all that. Okay, and then that one, we said that one contributes to the hardness of the bone. Okay, then of course we also looked at the organic component, which one we said is the protein component. Okay, and that protein component, because the inorganic component has taken 40%, water has taken 25%, then of course the organic component is going to make up about 35% of the bone extracellular matrix. That's what we said. But one thing that we get to know is that if you look at this organic component, which is also known as the protein component, we need that one so that we can lay the inorganic matrix on it. Okay, so we said that the organic component, we have the collagenous component, made up collagen type 1, After all, collagen is the most abundant protein type that we have in the human body. Okay, actually in the organic components, making up about 90% of it, and then the remaining 10% by non-collagenous components of the protein. And we said that the non-collagenous proteins components, we talked about osteocalcium, osteonectin, osteopontin. We talked about those ones. My friends, one thing you should know about these things is that whenever we talk about extracellular matrix, it's made up of what we call fibers and ground substance. Fibers and ground substance. And we've seen the ground substance, the fibers, and that is the collagen type 1 we are talking about, making up the collagenous protein of the organic matrix. And then, of course, when we look at the non-collagenous component, that one will form, of course, the ground substance. Okay, that is what we looked at the other time. Okay, so that is a useful thing that you should be aware of. So today we want to look at this kind of bone extracellular matrix that we are talking about. But before we do that, we told you that this extracellular matrix will be secreted by the cells. So before we move on with that, then let's look at the cells of the bone tissue. Now, whenever we talk about cells of the bone tissue, so one thing you should be aware, so cells of the bone tissue. Okay, now just a quick one before I move on to the cells. Now, I told you that you first need the protein matrix, which is the organic component, before you can lay the inorganic component. Now, for that reason, when you lay the organic component and it hasn't been mineralized by the hydroxyapatite, then we say it's an unmineralized matrix. It is also bone, only that it's not going to have hardness. Why? Because there's no mineral added to it. That portion of the bone, it closely resembles the bone, but it's not bone yet. Why? Because there hasn't been mineralization. That is why the late organic matrix that is put forward before we add the word inorganic component, we describe it as osteoid. Now, osteoid, osteoid. Okay, osteoid. Now, osteoid, that's the adjective describing that it resembles the bone, but it is not yet bone. Why? Because there hasn't been any mineralization. So now let's look at the cells. Now, whenever we talk about the bone cells, importantly is what I want you to be aware of, that we have 4 bone cell types. Okay, now the first one that we have to look at is what we call osteoprogenitor. Osteoprogenitor. Osteoprogenitor cells. Simply, these osteoprogenitor cells we are trying to talk about, you can simply call them osteogenic cells. Osteogenic cells. Okay, now remember that I told you that bone is connective tissue, and therefore we say something that all connective tissue, okay, will arise from an embryonic connective tissue, which we call it connective tissue mesenchyme. That's an important thing I want you to know. Now, this mesenchyme will contain stellate shaped mesenchymal cells. So connective tissue mesenchyme will contain stellate shaped mesenchymal cells. Now, those cells, because they can give rise to all other components of the connective tissue, okay, they have several potential of giving rise to all other connective tissue components. Then the word we use for them is that they are multipotent cells. For this reason, just to explain something to you, just to tell you something. Now, there are some terms that I want you to be aware of. Some terms. Before I come to my osteoprogenitor cells, you should be aware of cells, we call them unipotent. 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 My friends, if we say you are unipotent, then it means that you have only one potential of becoming a particular thing. Now, you are a stem cell. You are not fully differentiated. So, for instance, in this case, this osteoprogenitor cell will be committed in making the mature bone cell. Therefore, it has only one potential. Okay, it cannot become a cartilage cell. It cannot become a blood cell. You get what we are saying? And therefore, we say that it has only one potential, and so it becomes unipotent cell. Unipotent. Now, there's another cell. If you are having unipotent cell, there's another cell type that I want you to be aware of, and that is what we call totipotent. Totipotent. So there are some cells, we describe them as totipotent. Now, if you are totipotent, one thing I want you to be aware of is that you are capable, you are a cell, a single cell, but you are capable of giving rise to a full-blown organism of a particular species. Yes, that's what we are talking about. So for instance, when the male and female pronuclei, okay, those gametes, they fuse, we say fertilization has taken place, and therefore we form a zygote, a so-called unicellular cell, a zygote. Now, that zygote is capable of growing, becoming the embryo, several cells, becoming the fetus, coming out and surviving in extra-uterine environment. It means that you're going to become a full-blown organism. Therefore, the zygote is a typical example of totipotent cell. Yes. Now, there's another cell type that I want you to be aware of, and that is what we call pluripotent cells. Pluripotent cells. Typical example of pluripotent cells will be mesenchymal cells. Mesenchymal. Why? Because we've told you that if the word pluri has to do with many, plural, that's not single, that's not, unipotent, pluripotent, then it means that you are capable of giving rise to differentiating into different adult cell types. What do I mean by this? If I take the mesenchymal cell, yes, we said that all cells of the connective tissue will arise from connective tissue mesenchyme. And therefore, there are adult cell types that will be seen, mainly will be, of course, this kind of mesenchymal, mesenchymal cells, stellate-shaped cells I'm talking about. So for instance, I can talk about the mesenchymal cells. Okay, because the mesenchymal cells can commit themselves to become, let's say, the bone cell, the cartilage cell, okay, the muscle cell, okay, the blood cell, all these cells. That's what I'm trying to talk about. Another example that I can give over here for pluripotent cells, okay, will be, of course, the hematopoietic stem cells. Now, anything humo has to do with the blood. So the cells of the blood, okay, capable of giving rise to these adult blood cells that we look at. For instance, I have this, these cell types I'm talking about, hematopoietic stem cells I'm talking about, they can commit themselves to becoming the red blood cell, mature red blood cells. Okay, through something we call the myeloid series. Can become, of course, the monocyte. Okay, can become the megakaryocyte, which will eventually go through fragmentation, giving rise to what we call platelets, the thrombocyte. Okay, now they can also be in what we call the lymphoid lineage, where they can give rise to, of course, these kind of lymphocytes we're talking about. Okay, so whichever cell type we are talking about, basophil, neutrophil, okay, eosinophilic, all these cells we are talking about will arise from the hematopoietic stem cells. They have several potentials, therefore we call them pluripotent, cells. But my friends, there will be another cell type. That one will have unlimitless, so to speak, unlimitless, potentials. And therefore the word we use for them is multipotent cells. Multipotent cells. And usually for these multipotent cells, okay, for instance, this embryo, this zygote I'm talking about, the form that gets implanted is called blastocyst. Now the blastocyst is an important stage, okay, where cells can be extracted. Those cells, we call them stem cells. And those cells are capable of giving rise to, yes, all other cells we are talking about. Yes, importantly, if you look at what we call some cells, if you look at the embryo in the second week of intrauterine life, there are some cells, we call them epiblast cells, epiblast. they are typical examples of what you call, multipotent cells. Okay, why? Because they will give rise to all the 3 germ layers by way of ectoderm, mesoderm, endoderm. And my friends, your entire being over there, okay, is made up of all these things I'm talking about. This ectoderm, mesoderm, and endoderm. Okay, all the other cells, okay, will arise from these things, and therefore they become typical examples of multipotent cells. Okay, so that one I want you to be aware of. That is not really what I'm talking about, but what I want you to be aware is that I have some mesenchymal cells, which are pluripotent cells, and they have committed themselves to becoming the bone cell, and therefore the stem cell of the bone, which becomes unipotent stem cells. Therefore, it is undifferentiated, so to speak. We call it osteoprogenitor cell or osteogenic cells. Okay, so they closely resemble these mesenchymal cells. Okay, and what they are going to do is that they will give rise. Okay, they will differentiate. They will give rise to what we call the second cell type, which we call it osteoblast. Osteoblast. Now, keep an eye on the surface blast, because already the prefix osteo has to do with the bone. Therefore, the surface blast, what I want you to be aware is that whenever you hear the word blast, it means to form, to produce. Okay, that is what we are talking about. So that is the one which I told you something, that the extracellular matrix of the bone will be made by cells of the bone itself. And so it is this guy which I call it osteoblast, which will secrete the extracellular matrix of the bone. So produce it. For this reason, in fact, this cell, one thing we know about it is that generally we say it is cuboidal in shape. Okay, we say it is cuboidal in shape. And one thing we know about cuboidal cells is that yes, having almost the same length as the width. The nuclei or the nucleus will be rounded close to the base a bit. Okay, that's what we find over here. So I have the osteoblast. Now remember, I have a cell which is going to make this extracellular matrix, this protein component. It requires a lot of what? Protein synthesis machinery. Yes, you make sense. It makes sense because this guy is going to make the protein, the collagenous, non-collagenous, what have you. So it means that by way of organelles, this guy over here will be endowed with a lot of rough endoplasmic reticulum. Of course, some free ribosome may be around. There's supposed to be modification of this protein that we are going to make. And therefore, we need this kind of Golgi apparatus. At the end of the day, they will package these kind of product into vesicles, importantly. But importantly, we also need mitochondria. Why? Because this cell will be actively involved in production of extracellular matrix. Okay, so that it can make a lot of this kind of ATPs, the energy currency of the cell, okay, for various, active transport processes or active processes of the cell. That's important. Okay, now one other thing too that I want you to be aware is that this cell, we describe it at this stage as being euchromatic. The nuclei will be described, the nucleus will be described as euchromatic. Now the word eu means true. There is some biology at the senior high school. Okay, now there will be some light staining regions, okay, in the nucleus. It tells you that the cell is active, okay, in its replication, okay, and all that. So it will be euchromatic, importantly. Okay, now one other thing too that I want you to be aware is that this cell will also, because we said that after making the osteoid, remember osteoid, that is the uncalcified or the unmineralized extracellular matrix. You have to lay the mineral, the hydroxyapatite. Now for you to do that, lay a lot of that hydroxyapatite, one thing that I want you to be aware is that it means that calcium will have to be taken from the blood, peripheral blood, all the way into the bone. Yes. In other words, we will reduce blood calcium level, but we will increase bone calcium content. Why? Because this guy, osteoblast, will need to deposit the mineral matrix on the osteoid, the mineral matrix. Yes, that's what is going to happen. Okay, so for this reason, what we are going to see is that this guy will have to respond to a hormone. Okay, so what hormone will it respond to? So that it can admit a lot of the calcium into it. And that hormone, okay, is what we call, calcitonin. Okay, calcitonin. So we want to tone the blood calcium level. We are decreasing calcitonin. We are toning down the blood calcium level by bringing the calcium into, of course, the bone, so that this osteoblast will make use of it to deposit mineral matrix. Yes. In other words, whenever calcitonin is released into the bloodstream, then what do we see? Calcitonin is secreted by some cells. We call them parafollicular C cells of the thyroid gland. Initially, there was that notion that these parafollicular C cells were coming from something we call them ultimobranchial bodies. But my friends, that's not true. That's not true. Yes. They're actually coming from what we call some migratory cells which arrive from epiblast. We call them neural crest cells. Neural crest cells. You know, we have 3 germ layers: ectoderm, mesoderm, endoderm. Definitive germ layers. But my friends, because this neural crest cells is able to give rise to a lot of structures in the body, we now regard them as the 4th germ layer. 4th germ layer, yes. So they are migratory, can migrate anywhere, and they migrate into what we call this ultimobranchial body, so-called. So that what is going to happen is that in there they will give rise to what we call the parafollicular C cells. Okay, so just coming to stay in your house and perform my duty doesn't mean that, okay, you perform that duty. No, I did it. Okay, that is one important thing that I want you to be aware of. Okay, so that is that one. Okay, so in the presence of optimal amount of calcitonin, then we expect that rather we tone down blood calcium level, but we increase bone calcium content. Who is going to use it? The osteoblast is going to help deposit that calcium in there. But my friends, there's a catch somewhere that I want you to be aware of. Before this osteoblast can lay the calcium, it requires an enzyme. Yes, it requires an enzyme. And my friends, that enzyme, we call it alkaline phosphatase. Alkaline phosphatase. Okay, alkaline phosphatase. Now remember, this osteoblast can perform its work, but sometimes the activity will be so slow that it will be practically impossible to happen. And that is why we need enzymes, these biological catalysts, to enhance, the reaction rate. And for that matter, this osteoblast will need a lawyer. And who is that lawyer? By secreting alkaline phosphatase, importantly. Therefore, osteoblast, when we ask you, what enzyme activity does it demonstrate? Then the answer is simple. Alkaline phosphatase. As simple as that. Okay, so that is, one thing that you should be aware. That is osteoblast. Then there is one more thing that you should be aware of. Now, once this osteoblast has laid the extracellular matrix with concomitant subsequent calcification or mineralization of this extracellular matrix or the protein matrix, what we see is that this osteoblast will become trapped. Yes, it will become entrapped, my friends, and the name will change. The name will change from osteoblast because it's no longer going to secrete this extracellular matrix maximally. Now keep an eye on this word I'm trying to tell you, maximally. Okay, so it becomes something we call osteocyte. Now my friends, I want you to understand something. The word is called osteocyte. Osteo has to do with bone, and a cyte is the mature cell. So whenever you hear the word cyte, you are talking about the mature cell. And so the mature cell, what is it going to do? It's going to maintain. So that's the important thing. So mature cells, what do? They maintain the bone extracellular matrix. They maintain the bone extracellular matrix. So that is what we see. But my friend, something happens. The shape changes. So that this time around, the cell becomes oval in shape. Osteocytes will change from the original cuboidal shape of the osteoblast to oval shape. And it doesn't end there. What we see that it also presents with these processes. So in anatomy, anything that is coming out of the main structure, the name we give for it is process. Okay, so all these extensions that you see over here, we call them cytoplasmic processes. Cytoplasmic processes, which otherwise you want to call them philopodia. Okay, importantly. Now, please be mindful about this. One thing is that once I make this extracellular matrix, okay, that extracellular matrix of the bone tissue, that immediately surrounds these osteocytes, okay, we call it lacunae. Okay, so the plural form will be lacunae. So there will be extracellular matrix immediately surrounding. We have it everywhere, but the one which is immediately surrounding these osteocytes is given the name lacuna. So the singular form is lacuna, the plural form becomes lacunae. Okay, importantly, lacunae. This is something I want you to tell you, that we don't have lacunae exclusive to the bone. We also have lacunae in the cartilage cell. So we get to know later that the cartilage cells, the mature cells of the cartilage by way of the chondrocytes, will also reside in lacunae. Important, so get to understand that we don't have lacunae exclusive to the bone tissue. We also have lacunae in, of course, the cartilage. Now, we will have several of these osteoblasts making this extracellular matrix. They become entrapped in it, forming osteocytes. We have several osteocytes. Importantly, one thing I want you to be aware is that this osteocyte that we produce, okay, there will be adjacent osteocytes around, so they have to communicate. They have to communicate, and they will communicate through these processes. So another one will bring the process, and they will communicate. Okay, so let's say there's another osteocyte around here. So this one will have to communicate with this. That's what I mean. There will be that communication. Okay, also dwelling in its own lacuna. And so that communication means that these processes will have to run through some little channels. Okay, so that communication will be possible. Now, those communicating channels, little channels, which these philopodia or these cytoplasmic processes will pass through, are something we call canaliculi. Now, the word is canal, yes, but canaliculi, little canals, little channels, okay, for that cytoplasmic process to communicate with adjacent osteocytes. Okay, so that is, one thing that we see. Okay, now the next thing I want you to be aware is that this osteocyte, the word site is the mature cell. Now, what mature cells do is that they maintain the extracellular matrix, importantly. So that is something that I want to reason out usually with my students, that if I'm maintaining something, assuming someone has built a house by way of who? The osteoblast has built the house, and you are the osteocyte, you are going to maintain it. Does that mean that you will not produce the extracellular matrix? My friends, you produce it, but to be in minimal amount. Okay, so if there are any breakages, there are some mending somewhere, you have to do it. So even the osteocyte, we are saying that it is maintaining the extracellular matrix, it's not forming, but because it's maintaining, it may be producing some little amount of extracellular matrix. Okay, importantly. One thing that we know about this guy is that because it's not be relevant in producing vast proportion of this extracellular matrix, then it means that it is rather going to, have little protein synthesis machinery. Okay, we've said that already. And also this guy is going to be heterochromatic, having dark areas over there, which usually they cannot be replicated. Okay, that is one thing we find. Okay, that's what we see for its nuclei. Now, I told you that there are 4 cells of the bone tissue. 4 cells. This guy will not give rise to the next cell. Now remember, osteoprogenitor cell or osteogenic cells give rise to osteoblast, and osteoblast give rise to osteocyte. But my friends, osteocytes will not give rise to the next cell type that we have. Now, the 4th cell type is called osteoclast. Osteoclast. Now, the surface clast has to do with resorb, break the bone down, resorption. Resorption, yes, break the bone down. Here is where one important thing that I want you to be aware of. I told that it won't come from this. So where will it come from? Where will this osteoblast come from? My friends, it will come from fusion. Let me put it this way. Fusion of several. So let me say up to 20. Now, literature tells us that up to 50 monocytes. Up to 50 monocytes. Now, if you know monocytes are part of what we call agranulocytes, part of the white blood cells. Now, whenever they are in the peripheral blood, or let me say whenever they are in the bone marrow, we call them monoblasts. When they leave the bone marrow and they come into peripheral blood, their names change. Their name changes to become monocytes. Now, this monocyte, okay, whenever it moves into what we call any other connective tissue other than the peripheral blood. Now remember, blood is also connective tissue. So whenever it moves from the blood into any other connective tissue, the name will change. It will become what we call macrophage. Now, in other words, the macrophage is, the osteoclast is what we call the macrophage of the bone for bone resorption, bone breakdown. Okay? So now one thing is that I'll teach you something on bone remodeling. As you are sitting there right now, there's bone breakdown and there's bone formation. Bone breakdown by who? By the osteoclast. Again, for this osteoclast to break down the bone, what it means is that we are breaking down the bone, then we are releasing the mineral matrix and we are sending it into the blood. Is that okay? Which means that in osteoclast activity, then the calcium concentration in the blood will increase, while the calcium content in the bone will decrease. Okay, so that is what I want you to be aware of. So for that reason, what hormone will this osteoclast respond to? Okay, so what the important thing is that it will respond to a hormone, we call it parathyroid hormone. Parathyroid hormone. Now, in the presence of parathyroid hormone in the blood, which is secreted by some glands, in humans you have 4 of them behind what we call the thyroid gland. We call them parathyroid glands. They secrete this parathyroid hormone or parat hormone. And what this parathyroid hormone will do is that it will cause increased osteoclast activity, that is bone resorption, so that the calcium will be released into the blood. That's what is going to happen. And my friends, for this osteoclast to also do that, it also secretes an enzyme to help it in that regard. This time around, it is not alkaline phosphatase, it is acid phosphatase. Why? Because this phosphatase will work best in that acidic medium. We're talking about alkaline phosphatase in osteoblast activity. In osteoclast activity, we are talking about acid phosphatase. Importantly, yes, that's what I want you to be aware of. So that is what is going to happen. Resorb the bone. Resorb the bone. This is where something happens. Okay, there's one disease or disorder, we call it Paget's disease. Paget's. Which otherwise we call it osteitis deformans. Paget's disease. Now, whenever there's bone resorption, it is okay, followed by what we call bone deposition, bone formation. It is happening in you right now. Now some bones, for instance, bones of the hip, bones of the vertebrae, bones of the skull, sometimes, especially these bones, the osteoclast activity is not efficient, which means that there's minimal bone resorption. Meanwhile, bone osteoblast activity is efficient. Okay, going on. Now, some people will not even present with any, sign or symptom, only on accidental, diagnosis. When someone goes for an X-ray, they may see that, oh, this bone has grown abnormally. Now, we are supposed to remove the old bone. So remember, macrophages will have to resorb. That's the osteoclast. Will have to resorb this bone matrix away, so that no one can be deposited by the osteoblast. Okay, so that is, one useful thing that I want you to be aware of. Now, I told you that there's fusion of up to 50, so it can be 5, 10, whatever, up to 50 monocytes. And so we form a very giant cell. Now, you have a cell with a very giant whatever. So let's say I have several nuclei, with a lot of organelles, okay, in it, helping in bone resorption. This guy is what we call osteoclast. Yes, this is what we call osteoclast. And this osteoclast, what we see is that it's having this kind of, border at the lower aspect called ruffled border to help in the efficient bone resorption. Okay, now remember, it's having a lot of nuclei in it. For that reason, when you have a cell which is having a lot of nuclei, then we say that cell is multinucleated cell. So there's a multinucleated giant cell, which we also call a syncytium. Please keep an eye on that word, syncytium. Very important. For that reason, any multinucleated cell will be called syncytium. Later we get to know that, for instance, the skeletal muscle cell, okay, will also, be syncytium. We will see, the cardiac muscle cell forming, functional syncytium. Later section we explain that one to you because of some kind of disc. We call them intercalated discs. Okay, so this one is a structural, classic syncytium that we're talking about. Okay, that is, these are the cells that I want you to be aware of. Now, importantly, these osteoclasts will also have to reside in an area. We said osteoblasts, okay, after making the matrix, forming the osteocytes, will reside in what we call lacuna. The same way, we need to get a place to house these osteoclasts. And because they will be relevant in resorption of the bone, their area of residence will be called resorption base. So my friends, what I'm trying to say is that these osteoclasts that we have would dwell in where? In resorption bay. Resorption. Now, this resorption bay, importantly, we call it house shifts. Now, it's very big. It's an eponym for it. House shifts lacuna. So the plural form will be lacunae. Okay, house shifts lacuna. Okay, get to understand this point. Okay, so that is, one useful thing that I want you to be aware of. Now, in our next video, in our next section, okay, so these are the cells of the bone that you should be aware of. Now, in our next video, we are going to look at the types of bone tissue that we have by way of course, the spongy bone and of course, the lamellar bone. We are going to see them. And then we also look at, ossification of bone. So I'm very grateful for your time this evening. Have a good night, all of you, and may the good Lord richly bless you. Amen.